All right, so what we're going to be talking about today is the difference between parallel lines and perpendicular lines. Now, something you guys might want to put on your papers, all right now, put on your papers. There is a symbol for perpendicular that looks like this. It's an upside down looking T, all right? So anytime you see the word perpendicular, I want you to think 90-degree angle, all right? Parallel lines, the symbol for parallel lines literally looks like a pair of L's. So whenever you see a geometric symbol like this, where you have a pair of L's, that means parallel. So what we're going to be doing is we're going to be working on problem number 7. I'm going to zoom in so we can see it a little bit easier. There we go. Here's problem number 7. And our goal is to write an equation that is parallel to this line and literally goes through this point. Okay? So let's take a look at our original line right here. Does anybody know the slope of the original line right there? Correct, 1. I had a student that held up one finger. Unfortunately, it was not the middle finger, which is good. All right, means you're being respectful. All right. Now, does anybody know the y-intercept? Yep, close. -8. Very good. So right now, this is the slope. This is the y-intercept. Now, our new line I'm going to do in blue. Okay, y equals mx plus b. So just write this on your paper. Okay, write this on your paper. Now, if I wanted to make a slope that was parallel to it, what do you think would have to happen in order for these lines to be parallel? How about this? Ready? I'm going to draw a line. Would those lines be parallel? No. All right. How about like that? Those lines be parallel? No. So we have to figure out something. It's something you need to write in your journal now. All right. Here we go. Number 1 concept. Ready? Parallel lines have the, I'm going to put a blank, slope. What word do you think I'm going to put in the blank? That's right, the same slope. They have to have the same slope. If they don't have the same slope, then they're going to eventually intersect. So parallel lines will always have the same slope. So automatically, so you could write that down in your journal. This is where you write it in your journal. And then on your paper, right here, what do we know our new line's going to have the same slope as? A 1. Very good. Now, what is a slope of 1? Now, on your paper, if you would, a slope of 1 literally goes up one end, over 1. That's what it does. It goes up one end, over 1. So I can literally right now go up one end, over 1, and put a point. And I could go up one end, over 1, put a point. Well, I can keep this pattern, right? I could go down 1 over 1, right? Down 1 over 1, down 1 over 1, and eventually, what am I eventually going to hit? Ding, 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 ding. What did I just hit there? The y-intercept. Very good. And what would my y-intercept be, say, as an ordered 0 what? Nope, not 0, 4. 0, -4. So right here, put -4. So by the way, your very first answer to problem number 7 is y equals x minus 4. This is the line that is parallel to this line and has a y-intercept right there of 0, -4, and goes to the point 5, 1. So if you would please, on your paper, it's very easy. You just draw a line. Can you guys see how these are parallel now? They have the same slope. Now, for those of you who followed my instructions at the beginning of my classes, hey, can you please put this into Desmos? I'm going to show you guys what it looks like. So I'm going to Desmos. There we go. All right, so our first equation was y equals x minus 8. All right, and we had an ordered pair. And what was the ordered pair? 5, 1. And then we said the other line had to go through that point. Y equaled x minus 4. Does everybody see how the green line does literally go through the blue point? And these lines are indeed parallel to each other. So that's how you can kind of use Desmos to help you guys check your answers. And we're done. All right, next problem. Here we go. Moving on. So what do I want you guys to type into Desmos? I want you guys to type in negative 8, comma 7, and this equation right here, y equals negative half x minus 4. So let's go over to Desmos real quick. We'll type in our new ordered pair. And what was our new ordered pair, everybody? Negative 8, 7. All right, so I'll type it in. Negative 8, 7. There's our ordered pair. And our new equation is y equals, is it negative 1 half x minus 4. And I don't like this black line. I want to change it to something prettier. Let's go red. All right. So everybody, what we're going to have to do now is we have to find a line that goes through this point and is parallel to this line. Okay? It goes through this point and is parallel to this line. So get those typed in. Let's go over here. Now you guys know the answer to this. Parallel lines have the same what? All right, so what's the slope of our original line? Negative 1 half. Okay, so what will the slope of our new line have to be? Negative 1 half. It has to be. Okay, so right here, ooh, this is kind of tricky. I got to go what? Down 1 and over 2. So how do I go down 1? Can you guys see how these are actually going up by 2's? So this is a 2. What's that? That's a 4. That's a 6. That's an 8. So right here is a 7. So I got to go down 1 and over 2. So how do I go down 1 and over 2? I got to go down 1 and over 2 right there. So down 1 over 2. I got to go down 1 over 2. Wait a second. Why is that 2? Because the difference between here and here, it's been scaled by... Nope, not scaled by 1 half. It's been scaled by 2. See it? Negative 2, negative 4, negative 6, negative 8. So I'm going down 1 over 2. Down 1 over 2. It's kind of tricky. So here's my new line. What do you guys think this y-intercept is here? Negative 3? I don't think so. Positive 3, right? Positive 3. So what would my equation be for this? Y equals what? Negative 1 half x plus 3. Okay, this one was a little bit trickier because everything was scaled by 2. So how could we do this algebraically? So here's what I want you guys to do in your journal right now. So this is where I want you guys to go to your journal. Right now, in your journal, I want you to write down negative 8 and a 7. All right? In your journal, I want you to write y equals negative 1 half x minus 4. And in your journal, I need you guys to write, this was the original line, okay? This was the original line. And what I need you guys to do is we need to find our new line. All right, so our new line is going to be in the form of y equals mx plus b. Now, we already have our answer, but I want to show you guys how to do this without doing any graphing. All right, so what do we know for sure about our new slope? Our new slope has to be the same. So what's our new slope? Negative 1 half. Very good. Okay, so check this out. Everybody, this is my x value that I'm going to plug in right here. This is my y value that I'm going to plug in right here. And this right here, this is my slope. So I'm going to take this slope and I'm going to plug it in right there. This is how you could do it algebraically if you didn't have a graph and you didn't want to make a graph. So what's the number that I'm going to plug in here for my y value? 7. Very good. What number am I going to plug in for my slope? Negative 1 half. Very good. And what number am I going to plug in for my x value? Negative 8. Very good. And what's this going to allow me to do? It's going to allow me to solve for my b value. Okay? Now, we already figured out our b value through the graphing. We figured it out to be 3. So let's see if this works. Ready? So we have 7 equals, now a negative times a negative is a positive. What's half of 8? Yeah, very good. Now, how do I get rid of a positive 4? What do you have to do? You have to what? Take it away. And algebraically, what do we still get is our y-intercept? 3. So we get the same answer. Now the first way, what did we do? We did it by estimating and graphing. What way did we do it this way? We took our x value and plugged it in for x. We took our y value, plugged it in for y. We took our parallel slope, plugged it in, and what did we solve for? We solved for our y-intercept. And you can do this every single time. This is what I used to do all the time before these beautiful graphing calculators were made. All right? So let's go ahead and test out our answer. You guys ready? Let's test it out. Go to Desmos. Let's type in our answer. What did we get as our answer? Y equaled -1 divided by 2x plus 3. Does this line that we created literally go through the point that we started with right there? It does. That lets us know that it is correct. So parallel lines have the same slope. All right, one more and we're done with all parallel lines. Okay? This is your third and your last example. Now listen. Do you guys see this equation right here? Watch what happens when we go to Desmos. I'm going to clear everything out. Okay? Let's go back and take a look. -3, +3 works. So -3, comma, positive. We can plot that. But look what happens when I'm in Desmos, Texas star version. When I type in 4x minus 3y equals -12. Ready? 4x minus 3y equals -12. Can you guys see how this does not graph it? Okay? So what I want us to do is this is not graphable, but we can still figure out the slope and the y-intercept in standard form. So if you would please, on your paper, you don't have to do this in your journal. You already have this in your journal. Right now, I want you guys to write m equals -a over b. Okay? And the y-intercept equals c over b. So when we're in standard form, you got to know how to get your a, your b, and your c. So you got to find a, b, and c. Does everybody see it right here? We got ax plus by equals c. So what number goes with a for us? 4. What is b? -3, and c is -12. So this is what I need you guys to do on your paper, because I want to make sure you guys know how to find the slope and the y. Now you can clearly see the y-intercept, can't you? Where's the y-intercept? +4. Well, check this out. What's c? -12. What's b? -3. What does that equal? 4. So that's how we get the 4. What about the slope, though? -a, and what's my a value? 4 over my b value, which is -3. So if I get -4 over -3, what does that become? 4 over 3. What is my slope, everybody? My slope is 4 over 3. Now you can kind of see it from right here. Like here's the x-intercept. It goes up 4 and over 3. So what will the slope of my new line have to be? The slope of this line, the new line, what does the slope have to be? 4 over 3. What's the y-intercept? We'll find out. So from here, what could I do? I could go up 1, 2, 3. Ran out of room. 4. I'm going to put a little point right here. And go over 1, 2, 3. So can you guys use your imagination and see, like, it goes, you can go up like one more level? Can you guys use your imagination and kind of, even though it's not printed, can you see how that point would be right there? What's our new y-intercept? 1, 2, 3, 4, 5, 6. So that is at a what? A 0 and a, so plot it. And then you graph the dadgum line on your paper, just like that. Make them parallel as best as you can. So after you do this, what would be our final, what's the final answer for this? Y equals 4/3 x plus 7. Now I did not do this algebraically, all right? we did this what's called we did it graphically. We solved it by using what? The graph. So type this in to Desmos. After you write that down, type it into Desmos. Here we go. Y equals 4 divided by 3, x plus 7. And what was the original line? Y equaled 4 divided by 3x. Oops, not that right. X. And it was plus, was it plus 4? See how these lines are indeed parallel to each other. And it does go through that point. So that lets us know that this is the correct answer. So guys, last thing I want you guys to know about parallel lines. They always have the same what? Slope. That's it. Okay? Have the same slope. Okay, now we're getting into brand new territory. All right? So here we go. Everybody, right here, I'm going to zoom out real quick so we can read. In bold, it says, write the slope-intercept form for an equation of the line that passes through the given point and is what? Perpendicular to the graph of each equation. All right, guys. So, guys, what I need you to do right now is I need you in your journals. We're going to talk about perpendicular slopes. Here we go. This is the only other concept we're going to talk about today, right here. Perpendicular slopes. From now on, guys, from now on, I'm going to put right here, I'm going to put this, I'm not going to put it in, I won't put it in parentheses. I don't want you to think I'm multiplying, sorry. I'm just going to put the upside down t. So from now on, whenever I write this upside down t, what do I want you to think? Perpendicular. That's a heck of a lot easier writing one little symbol than spelling that word out over and over and over again. Okay? All right. You guys ready? Perpendicular slopes are, I'm putting it in capital, negative, keep going, reciprocals. Perpendicular slopes are negative reciprocals. Underline, underline. You're like, what the heck is a negative reciprocal? So I'm going to give you guys some examples, okay, of negative reciprocals. So please just put examples right here. I'm going to start out with an easy one, 1 over 2. Then I'm going to change it to 2 over 3. Then I'm going to change another one to negative 4. And then I'll do one in orange. Ooh, let's just do 1. Just like the slope of 1. Okay, so here's some examples. Now, what I'd like you to do right now is write the upside down t. Upside down t, there we go. That's the symbol for perpendicular. 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 All right, so if my slope was 1 over 2, my new slope will be negative 2 over 1. If my slope was 2 over 3, my new slope would be negative 3 over 2. If my old slope was negative 4, which is technically negative 4 over 1, then my new slope would be positive 1 over 4. If my old slope was positive 1 over 1, then my new slope would be negative 1 over 1. These are what's called negative reciprocals of each other. Now, their products will always equal negative 1. If I multiply this times this, it's negative 1. This times this, it's negative 1. Anytime you multiply these slopes together, they always equal negative 1. So you could also write that down. Their products are always negative 1. So here we go. Here's your test right now. Good luck. I'm going to give you guys a slope, and you tell me the perpendicular slope of this. Good luck. Write that down, and then you tell me what you think the perpendicular slope is. Don't tell me out loud, just write it on your paper. All right, so I paused the video. I'm going to point at somebody, and they're going to tell me the answer. I'm pointing at somebody right now. Negative 7 over 4 is correct. You made it to the sequel. Very good. All right, now I'm going to go over one more. All right, I'm going to try to make it tricky. Here we go. Here's a tricky one. 2. What would be perpendicular to a slope of 2? So I had a student say negative half, which is totally correct. That would be perpendicular, because technically 2 is what? 2 over 1. Okay? So remember, if it's a whole number, what do you have to remember how to do? Change it to a rational number by putting it what? Over a 1. And that'll maybe help you know how to do what's called the negative reciprocal. What does negative mean? It means if it's positive, it's negative. If it's negative, it's positive. What does reciprocal mean? Like the flip. So how about this? To help you with your definition, put a little arrow next to reciprocal and write the word flip. Next to the word negative, just put, hey, it's going to be the opposite. What does opposite mean? If it's positive, then it becomes negative. If it's negative, it becomes positive. If you want a math cuss, you can say flipping opposites. All right? All right? I know. Perpendicular slopes are totally flipping opposites of each other. So that's what we're going to be working on today, right now. Flipping opposites. So zoom in, guys. Zoom in. Right here. I want you guys right now, on your papers, not in your journal, on your paper, I need you guys to plot the point 4, 2, right there. Plot the point 4, 2. Now, also on your paper, what is our slope? Our slope is a half. What's our y-intercept? 1. So put a point right there, which is my y-intercept. And as you go up 1, over 2, up 1, over 2, down 1, over 2, down 1, over 2. And draw a beautiful straight line, which is our original line right here. Once you've done that and you've plotted the ordered pair, 4, 2, I need you to type these into Desmos so you can clearly see that you've done it correctly. So up 1, over 2, up 1, over 2. Write them down. Get it done. So I'm going to go over here to Desmos. I'm going to type in y equals 1 divided by 2x plus 1. And then I'm going to write down the ordered pair, which was what? A 4 and a 2. So now that I have that, I'm ready to go. So here's your first challenge. If my slope is 1 over 2, what's the perpendicular slope? You're right, negative 2 over 1. So from right here, everybody, from right here, what I'd like you to do is I'd like you to go down 2 over 1 and put a point. Well, I ran out of room. Well, if I can go down 2 and over 1, I can go up 2 but over 1 to the left. And I can go up 2 and over 1 to the left. Here is your new line. Can you see how it makes a 90-degree angle? All right? Now, guys, I don't know what the line is, but here's what I do know. In y equals mx plus b, I know the ordered pair, and I know the slope. So guys, in your journal right now, in your journal, I need you guys to write this down under your perpendicular section, okay? Right now we're dealing with perpendicular lines. We're dealing with perpendicular lines. This is your slope, and there's the ordered pair that you have to use. So while you guys are writing that down, I'm going to carefully set it up. There's my x value. I'm going to plug in here. There's my y value. I'm going to plug in right there. And here's my slope that I'm going to plug in right here. Okay? Just remember, this is my x value. This is my y value. What number am I going to plug in for my y? The number 2. What number am I plugging in for my slope? Negative 2. What number am I plugging in for my x coordinate? 4. And that's going to help me solve for my y-intercept. So right now, here's my equation, everybody. I know it's y equals negative 2x plus something. But what am I solving for? I got to solve for my y-intercept. Why am I not doing it graphically? Because you guys see I have to keep doing what? Up 2 over 1, up 2. It puts me way, way, way up there. I could do it graphically if I had a bigger piece of graph paper. This is called the origin. No, I'm just saying that lets you know that that's the origin. We always graph from the origin, 0, 0. Okay, so here we go. 2 equals, what's negative 2 times 4? Negative 8. If we add 8 to both sides, we get 10 equals b. What does that let us know? That lets us know our y-intercept is at what number? 10. So right now, I know my y-intercept. It's at a 10. So what's my final answer for this problem in slope-intercept form? No. Y equals negative 2x plus 10. So guys, what I want you to understand, this is my answer. Why did I not do this graphically? I didn't do it graphically because what would I have to keep doing? I'd have to keep going up 2 over 1, up 2 over 1. And where would it all be? All the way up there. So how could we check it in Desmos? It's very easy. Type in your answer. If your answer doesn't go through this point, then you got it wrong. Can you guys see the right angle that's formed right here? If you can't see the right angle, I'll prove it to you. Here, I gotta take a screenshot real quick. Screenshot, okay. Now I can put it right here, and I can rotate it, and hopefully you guys can see that that fits in there perfectly. There's the right angle right there, okay? All right, all we got is one more to do, okay? One more to do, everybody. So right now, I'm going to zoom out just a little bit, okay? So here's what I'd like you to do. We're doing one more right now. Here's your x value. Here's your y value. I need you guys to plot 2, negative 3 right here. 2, negative 3. Next thing I want you to do is I want you guys to identify what the slope is and what the y-intercept is of the original equation. What's our slope? Negative 2/3. What's the y-intercept? 4. Very good. Let's plot it. Go up 1, 2, 3, 4. Put a point. Go down 2 over 3. Down 2 over 3. Put it right about there. Okay? So kind of you have to go over one more. I can also go over 3 and up 2 and put it right here. Once you plot those points, carefully connect the dots. Carefully connect the dots. Hopefully, you can clearly see that this goes down 2 units and over 3 units. That's what a negative 2/3 slope looks like. Okay, so here we go. What's our new slope? If we have a negative 2/3 slope, what slope's going to be perpendicular to that? What's our perpendicular slope? If it's a negative, this has to be a positive. If it's 2 over 3, it has to be 3 over 2. So all I have to do now, guys, is go up 1, 2, 3 over 2. Now, I'm going to do this graphically. Instead of showing you all the math, remember, all the math was what? Doing all this. Instead of doing all the math, once again, I'm just going to do it graphically, because graphically will still work here. What do I have to do if I go up 3 and over 2? What can I still do? I can go over 2 and down what? 1, 2, 3, which puts me right about there. So let's count. Ready? 1, 2, 3, 4, 5. Where does it put me at? What's my y-intercept? 1, 2, 3, 4, 5. Negative 6. So what does this represent? My y-intercept. What's my slope? Positive 3 over 2. So what's my final answer for number 11? There we go. That's going to be my final answer. Now, how could you check to see if you actually got it correct? You could type it into Desmos and make sure it passes through to -3, which is this point right here. So right now, if you would please, type in 2, -3. I'm clearing this out, clearing it out, clearing it out. We're typing in 2, -3. We're typing in our old equation, which y equals -2/3 x. Was it +4? I think that's what it was. And let's type in our new answer. Y equals 3 divided by 2x minus 6. And that proves to me that we actually are going through this point right there, 2, -3. And once again, it does form a right angle. All right. Right now, guys, I want you guys to try to do number 12 all on your own. The original slope, just so you guys know, is 7/1. The perpendicular slope will be -1/7. So your new answer, just so you guys know, your final answer should start out y equals -1/7 x plus b. All you got to do is take this ordered pair, 6 and 4, and simply plug them in and solve for b. So I'm going to go ahead and graph this. You guys have this is going to be your homework problem. You're going to try to come up with the right answer. I'm going to go ahead and start the problem right now. Here's my y-intercept. I got to go up 1, 2, 3, 4, 5, 6, 7/1. That's a pretty steep slope. That's our original line. I know my new line has to be -1/7. I'm going to take the x value, plug it in here, take the y value, plug it in here. I'm going to take a 4. I'm going to plug in a 6. I'm going to solve for b. 4 equals -6/7 plus b. So it looks like I got to add 6/7 to both sides. How do I add 6/7? Well, I'm going to change this to 7s. I'm going to put 28/7, which is 4, plus 6/7, which adds to 34/7. That's an ugly number. So it looks like my y-intercept is 34/7. So my final answer would be -1/7 x plus 34/7. Can a ridiculous answer like this be the correct answer for a line that's perpendicular to our original one? Absolutely, because it passes through 6, 4. 1, 2, 3, 4, 5, 6, up 4 right there, and it's a -1/7 slope. So I'm going to type in my answer, see if it works. All right, you all have a good day. 6, 4, y equals 7x plus 1, and our perpendicular slope is y equals -1 divided by 7, x plus 34/7. Nailed it. Went through that point right there. This was the correct answer. Y'all have a good day.